Hello, today we're going to be covering truck company operations with a focus on basic forcible entry approach. During this class, we're going to focus on a few different things. We're going to focus on the physics of levers as they apply to forcible entry. We'll be looking at the different forcible entry tools that we're going to be using in a typical forcible entry problem. We'll be covering residential versus commercial construction as it applies to the forcible entry problem. We'll be looking at door size up, and we're going to focus our practical on through the lock forcible entry as well as conventional forcible entry. Within the class today, my goal is to take the rookie firefighter or somebody fresh out of academy, or maybe a firefighter that works in a region of the country that doesn't see a lot of forcible entry duty, and to give them some tools and a basic approach that will improve their chances of being able to meet whatever problem they find in the field. Today we see the fire service shifting from a focus on the value of these forcible entry techniques using hand tools to a power tool forcible entry approach. Although this is an effective solution to many problems, there's still a place in the fire service for the art of conventional forcible entry using hand tools. Examples of this would be tenement building type of structures, also commercial structures with interior doors that are reinforced depending on security needs. On slide 7, you're going to see an example of the different classes of levers. These are simple machines that we're going to use to gain mechanical advantage, whether that's increased force or increased range of movement. We're going to be using these tools in myriad ways to overcome the forcible entry problems that we run into. This slide is really meant to give you an idea of the glimpse into science and the science behind what we're doing here. It's not necessarily going to be value added while you're working an actual forcible entry problem. The Halligan bar with the Pro bar design is a progression, the latest progression of one of the first tools that was purpose-built for fire duty. The Halligan tool was originally a combination of the positive aspects of a Kelly tool and the positive aspects of a claw tool. They took these two tools and Chief Halligan improved them by adding 3 driving surfaces. So this tool increased greatly in efficiency. The Halligan tool is pronounced just like that, H-A-L-L-I-G-A-N. It's often confused with a knockoff design called a hooligan bar. This is an inferior tool. The 3 features typically associated with a Halligan bar are the pike, the adze, and the fork end. Now, as I alluded to earlier with the Halligan hooligan statement, not all Halligan bars are created equal. The Pro bar design was an improvement upon Chief Halligan's original design. They took the fork end of the tool and they thinned that tool out. This allowed the tool to fit within the newer forcible entry problem that they were seeing in the US. This would be tighter construction features, which rendered the original Halligan design less effective. You can see the design on the hooligan bar here, and it has a much fatter body. That is a shortcoming when we're dealing with tight structural components, whereas the Pro bar has a much thinner profile, allowing better penetration and greater force to be created. The fork end of the tool will often be used for inward swinging forcible entry problems, whereas your pike can be used to bury the tool into a jam for a single person force technique, or anytime we need to pierce any kind of material. The adze will be used on tighter surfaces. You can use it for gapping a door. Also on outward swinging forcible entry, this will typically be your initial tool of choice. One of the other primary tools used within forcible entry in the fire service is the flathead axe. You can see this tool in a 6 or 8 pound head. The larger weight on the 8 pound will allow some additional driving force with the tool. That additional tool weight is somewhat of a trade-off. You're carrying 2 additional pounds with you. So on a lighter forcible entry problem, as dictated by your size up, you may choose to go with a lighter head weight to conserve energy. The flathead axe can be seen with a fiberglass or a wood handle, and they both have their benefits. A wood handle is readily available, It has excellent absorption of shock when you're striking or using the tool, and it's easy to replace when you damage that handle. The fiberglass handle can also absorb an excellent amount of shock while using the tool, but it's much more difficult to replace, involving epoxy and even the process of tearing the tool out of the handle. Another disadvantage of this tool is typically the shaft of the tool will not be checkered, so it can be difficult with fire gloves on to grip the tool above the base of the handle. The axe carries value for cutting and chopping duty on the fire ground. It can be used to set the halligan in forcible entry, and that's where we're typically going to see it be used. It can also be used as a spacer to hold progress while you're forcing a door. Care of this tool will include a focus on the head of this tool. The rear of the flathead tool should be filed to make sure that there's no mushrooming of that head to allow for a square strike on your halligan. The cutting surface should be sharp but not over sharp, and if you have too sharp of a cutting surface, you're going to run into a problem where building materials such as nails will chip the blade out and make it less effective. When the flathead axe is carried with the halligan bar, this is commonly referred to as the set of irons. The sledgehammer, when added with a halligan tool, could be called the heavy iron set, and this can be used for a heavier commercial application. The sledgehammer can also be used for battering down a door when that's your chosen tactic, or cinder block and masonry walls. We talked about the pros and cons of the wood versus fiberglass handle when we were speaking about the flathead axe. The same applies here. There's some additional durability with a fiberglass handle, but it can cause much more trouble when you're trying to replace that tool shaft after breaking it. There are also several tools commonly used for through-the-lock forcible entry. These tools would be the K tool, the Rex tool, the O tool, and a shove knife. The K tool is typically used with a flathead and halligan bar. This is going to be used, originally designed for narrow-style metal doors with mortise locks. This tool is made to slide behind the collar of the face of the lock, and then you use the halligan tool to pry that lock cylinder off of the actual door. One drawback to this tool is that if the lock is either too deep or too wide, the K tool will not be able to get a good bite on that lock. That is where the design for the Rex tool came from, and there are several different designs available on the market. The idea of these tools is they've taken away the issue of the lock being too deep. The O tool is another solution to the shortcomings of the K tool. It will be used and set with a flathead or halligan, and like the Rex tool, you will pry that cylinder out of the lock and then use a keyway tool to function the lock. The keyway tool in one of various versions will be found in the K tool, the Rex tool, and the O tool as part of the kit. This tool is used to function the lock after you've pulled the cylinder out of the door. Each tool surface has a different application. The bent surface here is going to be used on mortise locks, and this flat, more knife-like surface is going to be used on a typical rim lock. The modifications to this cat's paw, very small cat's paw, has allowed it to be used as a keyway tool on one end, with a screwdriver or other tool being used to function the rim locks. The shove knife was originally designed to function the simple spring latch on fire tower doors. There's still many applications for it today. Typically a very simple lock system will allow you to be able to push the tool into the door and simply function the spring latch. It's most effective on outward swinging doors, but it can be used on a very loosely set inward swinging door. On your typical key in the knob lock today, you'll often see an anti-loitering pin. This pin prevents the latch from being functioned while that anti-loitering pin is partially depressed. The way to overcome this is to apply pressure to the door to allow the anti-loitering pin to seat into the striker face. I've just used several terms and spoken about several tools which the individual may or may not be comfortable or acquainted with. These tools are going to be used in a typically less emergent setting. You're not typically going to use a through-the-lock approach for an active firefighting operation. But there are situations and door styles where this could be a quicker method of entry and safer than your conventional forcible entry, like large plate glass doors on the fronts of many businesses. Within hydraulic tools for forcible entry applications, we typically see the rabbet tool and the hydra ram. The rabbet tool is an older design which took 2 people to function. The hydra ram allows for a single person operation and will provide about 4 inches of throw and 5,000 pounds of force. It's typically used on an inward swinging door. The most common power saw used for forcible entry in the fire service would be the gas-powered rotary saw. This tool provides the option of using several different blade types and cutting hardened metal as well as concrete or wood structures depending on the type of blade that you're using. We can use these saws to cut fences, locks, cutting through metal or wood doors or structures, cutting sheet metal siding on a pole building type of structure. It can also be used to cut security bars. Typically, you'll see this tool with an abrasive wheel, which will be used for cutting heavier metal structures. There are also diamond-coated wheels and carbide wheels. These are going to allow you to cut different structures and materials. In a mostly wood application, a carbide wheel would be perfectly appropriate, while cutting concrete or in an application where you need to cut a greater amount of metal at a more significant depth, a diamond wheel is not going to wear away like your abrasive wheel will. The rescue chainsaw is another tool that's commonly used on the fire ground and has some applications in forcible entry. This saw should be equipped with a carbide tipped chain, which will allow it to cut multiple materials without dulling. This tool can be used for door-to-window conversions. It can also be used to cut sheet metal structures, roofs as we typically know, and wood doors. You can use it to function the panic hardware. Many companies nationally will use the depth gauge for ventilating roofs with these chainsaws. That should be removed when you're using this for a forcible entry application. That's because the depth gauge won't allow for the necessary depth of cut that we need in the forcible entry application. As opposed to focusing on all the specific options for the residential versus commercial approach, I'd like to spend some time looking at the materials. Typically, you're going to find a few different types of doors. On commercial occupancies, you might see a tubular aluminum door with plate glass. You'll see hollow core doors typically on interior residences. And then you have slab doors, which will often be used on your front doors or outside exits of a building. You can sometimes see a metal-clad slab door, which is referred to as a calamine door. The reason we talked about these 3 different styles of doors is that depending on which one you run into, you're going to have a different tool choice and you may use different tactics. Next, we will look at the frame and surrounding structure. The door frames will typically be either wood or metal, and the structural surround will typically be wood, metal, or a masonry material. Wood frames and structures are going to allow us some benefits, and that's going to be additional flex. The door, the frame, and the structure will all be able to absorb some of your force and flex to allow you to force these doors more easily. They'll also be more likely to splinter when force is applied. Masonry and metal frames and structures are a different problem. They're typically going to identify a heavier forcible entry problem. These type of frames and structures will tell us that we may need a different tool choice. We may need to call for a power saw while we're beginning our attempts at hand tool forcible entry. With the masonry structures, it may be necessary to batter the door in order to be able to crumple it and create the space you need to force these types of doors. Going back to tubular aluminum doors for a minute, this type of door can be one of the specific examples where we may consider a through-the-lock approach. That is due to the large amount of glass that we're going to, broken glass that will be created when we break these types of doors, and we cannot use conventional forcible entry without typically breaking that glass. During your initial size up for forcible entry, there are some considerations that you want to look at. What is the emergency you're responding to? Is this a water problem where you can take some time, or an active interior firefighting operation that the speed of entry needs to be greater? When you're looking at construction materials and features, typically the lighter the material, the simpler your forcible entry problem should be. That said, additional security features added by the homeowner or occupant can pose significant problems during forcible entry operations. The type of occupancy that you're responding to can give you some clues as to your forcible entry problems. Commercial structure in a strip mall in a lower rent end of town has a greater likelihood of additional security features, stouter materials, and greater reinforcement on alternate exits like the rear of the building. The location of your door can give you some clues as well. The typical main entry point used by a building occupant is going to be less secured or able to be opened more quickly due to their constant use of this opening. Whereas the rear of the structure could see static drop bars and other types of commercially available or homemade locks and locking systems. The number of locks that you find on a given entry point could tell you a little bit about how much time it's going to take to force that door. If it's your only option for making entry, you may have to make do and just finish the job. This is also a point where you may consider other openings, either a different door or using a window in a wood frame structure. You could easily do a window to door conversion. All too often, our forcible entry problems are not these formidable structures with multiple locking mechanisms, and that only increases the importance of practicing the basic principles of hand tool forcible entry. After you've made the first steps into the door size up, you're going to take a closer look at the specific entry point that you've chosen. The first rule is, as we've all heard multiple times, try before you pry. We've all seen an example of a firefighter in the excitement of the emergency call not trying that door lock and therein causing additional time for forcible entry and additional damage to the structure. Next, where are the locks that you can see on this door? If a lock is out of line with your typical mechanisms you would expect to find, this could be a clue to a different style of lock like the police lock. Additionally, carriage bolt heads in different configurations on your door will be another clue that will typically tell you there are additional locking mechanisms that you will need to overcome to complete forcible entry on this door. The presence of deadbolts and other locking mechanisms will often tell you that you could have additional difficulties in forcing this door because the locks will have a greater throw into the jamb and require more force to be able to overcome. Next, test the door. You want to look at the door and strike the door high, mid-level around your main expected locking mechanisms, and then again down low. This is going to give you a clue to any additional locking mechanisms that aren't readily obvious from the outside of the structure. When you notice these additional bolt heads or unusual locations for locking mechanisms, this can be a good time to notify the officer that you are expecting a more involved forcible entry, or an excellent time to call for a power saw if you expect that to be needed. While you're testing that door, notice its fit within the jamb. Is there a lot of movement while you're striking the door? This can be a clue as to the overall workmanship and condition of the door. A looser door will often be easier to force. Another point often forgotten is after you force this door, whether through the lock or with conventional hand tool forcible entry, you need to control that door. That could involve impairing one of the hinges or a door closing mechanism, or blocking the door open or chalking it with a tool or a wedge. There are situations where through the lock method of forcible entry can be quicker than your conventional forcible entry. A lot of aluminum style doors will have some kind of security features like metal bands on the inside of these doors. This can take significant time and energy to overcome. Using the through to lock method can also allow to secure the structure after operations and for you to control your ventilation path during fire operations. If we batter a door down, we can run into an issue of not being able to reclose that door, and we've now altered the ventilation path, and there are points in a firefight where that may be very relevant. Using a through to lock method will allow us to keep any ventilation path that we would like intact. When done properly, through the lock methods will also create little or no damage to the structure or door itself. This can result in much lower repair costs for the building occupant. These techniques require training and constant practice to be proficient at. That's going to increase your value on the fire ground. Within many companies, especially a smaller fire department, there may be a few key individuals who have the passion to be able to really refine these skills and bring it to the rest of the company. And because this equipment is so affordable to purchase, it can be a real value added for very little cost. We're going to look at a few different styles of locks that we're going to commonly find in the forcible entry setting. Those would be a key in the knob lock, which is typically found on interior doors. It can be a standalone locking mechanism or have additional locks with it. The next would be a tubular deadbolt. In our region, it's commonly found on your exterior points of entry on a house. You can also see the tubular deadbolt in commercial settings. A consideration when you see these deadbolts is that the throw of the lock is greater than a key in the knob lock, and you're going to have to use more force to be able to open this door. The next kind of lock that you're going to see throughout most communities is the mortise lock. And this is a lock that's seated into the door, in a pocket in the door. It can have a latch and lock assembly or a lock alone. You'll also see them in tubular aluminum doors as the main locking mechanism. The mortise lock has a threaded cylinder mechanism held in place by a set screw. This is one of the types of locks that we can look at a non-destructive through the lock form of forcible entry on. The next lock is a rim lock. This is typically an add-on lock that will be in addition to other locking mechanisms or a key in the knob lock. The mortise lock is the one of all of the different locking mechanisms that has a threaded cylinder. This is going to allow us to look at operating this lock in a little bit of different fashion. If there's no protective shroud around the lock face itself, sometimes we'll be able to use a set of vice grips and spin that cylinder out of the lock body. As you can see in slide 20, the back of the cylinder for the mortise lock has a camming mechanism which sits within the door and functions the locking mechanism itself. The principle used for this is called the 5 o'clock to 7 o'clock method, and that is when we put the keyway tool into this doorway, which we'll show you in the video, you depress this pin and you swing the lock open. This can be done with little or no damage to the occupancy. This threaded cylinder is typically held in place with a soft set screw, which by making a small clockwise advancement of the cylinder before you spin it off of the face will typically break this set screw. You'll notice that the camming mechanism looks much like the 90-degree bend on your keyway tool. That tells you that the keyway tool with the bent end is going to be the correct tool to open this lock. The rim lock will be held on by set screws from the back of the door. These will often have a flush-mounted face, which can make the K-tool difficult to use on these locks. An O-tool can be used in this setting to dig into the door behind the lock, or you can use a Halligan or a flathead axe to smash the door above the locking mechanism to allow you to get the K-tool or Rex tool onto the lock face itself. When you pull the cylinder, in slide 21 you'll notice that there's a knife-like stem coming off the back of that lock. This tells you that the straight end of the key tool is going to be the correct tool to function this lock. Sometimes there is a shutter on the back of these locks that will not allow for manipulation of the locking mechanism. And at this point, you can take the pike end of the Halligan, set it on the back of the lock, and then use the flathead axe to drive that lock off of the back of the door. When time is of the essence, conventional forcible entry will typically be the solution on the fire ground. There will be additional damage done to the structure, often destroying the lock side of the frame, but speed will make up for that. These techniques require a sound understanding of the principles that you'll be applying to the door, and they typically require ongoing training and a strong team approach to forcible entry. As we mentioned earlier, when you've identified that you're expecting a more difficult forcible entry, this can be a reasonable time to call for a power saw. One thing to consider is your fire environment behind these doors. If you're expecting significant fire once you force an entry point, make sure you have a charged hose line in place prior to completing that breach. And why is practice so important with these seemingly simple skills and tools? That's because the teamwork involved in effectively carrying out these processes is an extremely perishable skill and must be practiced regularly. Gap set force is the process we're going to use to gain entry into a door. The first step is gapping that door. We can use the adze end of the tool or sharp blows depending on how tight the jamb and the door fit together. After we've created a purchase point, the next step is to set the tool. We're going to do this by driving the tool to the depth, an appropriate depth to reach the back of the door jamb or the back of the door surface, depending on whether it's an inward or outward swinging door. After the tool is set, we're going to force the door. This will be the application of force either inward or outward to overcome the locking mechanisms on the door. Next are the responsibilities for each member of the forcible entry team. The Halligan firefighter's job is to position the Halligan correctly within the doorway to allow it to be driven in to force this door. Typically, the firefighter is going to start on the door side of the Halligan tool, and he's going to call for hits to drive the tool in, and he'll call stop once that tool is appropriately set. Again, his main responsibility is correct placement of the tool, taking care not to drive the tool into the door jamb, which will impair any ability to create the force necessary to drive that door. The axe firefighter's responsibility is to provide controlled blows to the Halligan when called for, and then to help control the inward swing of the door after the tool is set as the door is in the process of being forced. A common mistake is for the axeman to continue driving the tool even when it hasn't been called for. This can result in either a missed blow that could injure the Halligan firefighter or an improperly driven tool. The inward swinging door will have a lack of hinges showing from the exterior. This is your first clue to the type of door that you're dealing with. We'll find these on many residences and entries to commercial occupancies. The plan A for an inward swinging door will typically be using the forks of the tool with the bevel towards the door. This is going to allow you to drive the tool until you've set the forks behind the back side of the door jamb. Outward swinging doors will have hinges visible. These are also doors commonly found on commercial occupancies or alternative exits to a commercial structure that will be a good spot to look for additional bolt patterns, carriage bolts on doors, and can commonly be more reinforced than a main entry. An additional feature that you'll find for added security on residences is the security screen door. This is typically going to be a metal frame with either an extruded metal infill or some type of laminated glass. These doors are going to typically need to be forced prior to forcing entry on the main door. When faced with the extruded metal fill, you can look at applying sharp blows with a flathead axe or Halligan near the locking mechanism to break some of the welds holding that web on and be able to access a thumb lock if the inside of the lock is not keyed. Another common added security feature is the static or drop bar. This is typically going to be a 2x4, 2x6, or a metal object thrown over the back of a door structure, holding it closed. Usually the board or metal object will sit into some kind of pockets, either on the back of the door itself or into the wall or frame. If the static bar brackets are mounted to the door, you'll be able to identify this on your size up, and these bolt heads can be either cut or driven through the door. If the brackets are mounted to the interior of the structure, then you may not see this. You're going to have to identify it as you have additional trouble forcing this door. At any rate, the presence of multiple carriage bolts or locking mechanisms on any door is a good time to consider calling for a power saw. So in closing, as we're approaching these forcible entry problems in the field, I want you to remember a couple basic things. First, try before you pry. You've got to practice that skill and make it a part of your ongoing training. Otherwise, you have a greater chance of forgetting it while you're under stress working on an actual problem. Next, use your time on the training ground as the valuable commodity that it is. Try to increase your skill level on the training ground so that the lessons can be less painful in the field. And lastly, when you're looking at your progression through tactics that you'll have to use on any given problem, try to make your plan A skill that you and the team you're working with have practiced before. This is a tough time to go out on your own where your team members don't understand exactly how to support you. First, I'm going to check the door, make sure it's locked. Next, I'll set the tool, gap it. Then I'm going to have my axeman provide me blows. You ready? Yep. Hit, 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 stop. All right, tool set. The key to effectively completing these type of problems is communication and excellent teamwork. Now we're approaching an inward swinging door. First, I'm going to approach the door. I'm going to check it, top, middle, and bottom, looking for any locking mechanisms that might be in play. I think I have a main locking mechanism here, so if there was a knob or a lock in place, I would go 6 inches above or below that. Now I'm going to set my adze behind the door, stop, and I'll start to gap the door. Next, I'm going to bring my axeman in. You ready to hit? Yep. Hit, 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 stop. And now the tool is set. I'm going to move around to the other side of the tool, and now it's time to force this door. Okay, at this point we may run into a problem with the locking mechanism not having failed. At that point I'm going to bring my axeman back in and we're going to capture the progress that we've made. Come on in, I want you to sink your axe right in here. Copy that? Okay, well good. Okay, now if I've already cleared the jam partially, I can switch around to the adge end of the tool, and this is going to give me additional throw for forcing this door. All right, you can remove the axe. What I have here is a mortise lock on an aluminum style door. First, I'm going to try to use my K tool to pull this lock cylinder. When I try to set the K tool, I notice that there's not enough room between the door because it's recessed in this jam. The tool's not going to set appropriately. So I'm going to have to use another method. Being as this mortise lock has an unprotected collar, I'm going to go ahead to plan B. I'm going to take my vice grips and I'm going to clamp them onto the outer face of this cylinder without grabbing the sliding collar behind it. I'm then going to give a short clockwise motion and then unscrew the cylinder. Now that I've removed the cylinder, I'm going to use the bent end of the key tool. I'm going to depress the pin and then function the lock, swinging the bolt open.